Percent composition. When we say percent, we mean percent by mass, okay? And what are we looking at in terms of its percent? It's percent by mass of each element in a compound. This is actually extremely easy. Like, I probably could have just sent you home to learn this on your own, but we need to know it to do the next thing we're going to do, so we're going to go through it right now. So, what is the percent composition of sodium bicarbonate? Well, first of all, we know that sodium is +1, and we can look up bicarbonate, which is CO3 minus, and so the formula is NaHCO3. So, how would you know the percent by mass of each element? Well, you write out each element and you say, oh, I have sodium with a molar mass of 23, and I have one of them. I have hydrogen, which has a mass of 1. I have carbon, one of those with a mass of 12. And then finally, I have 3 oxygens in that compound, which gives me 3 times 16 is 48. And then finally, I know my total mass is 84. Would it be easy enough to figure out what percent of 84 is sodium? Yes, right? Do we need to do anything more on this, or are we good? We're pretty good? All right, I will let you read the other examples and just do a couple things on your own, just so you can do it. But it's literally that simple. Find your molar mass and do the division. Be like 23 divided by 84 times 100. Boom, done. Is good? Excellent. 5.7e, this is on page 121. We do not do it by volume. It's hard to find the volume of each element because you'd have to know the size of each atom, and yeah. And then what percentage of it is empty space, and yeah. We can do solutions by volume, but yeah. So this leads us to another concept which you are already familiar with, and this is on page 121. We are going to be finding the empirical formula and molecular formula from the percent composition. Now, do you remember the steps for finding for finding empirical formula? What do you need to know to find the empirical formula? You need to know not the molar mass, but you need to know the mass of each element, yes? So you need to know the mass of each element, then what do you do with that? Mass to moles, and then what do you do with those moles amounts? You divide each of them by the smallest quantity, and then if you end up with fractions, you times till whole, okay? So there's nothing new here either, which is why we can teach this entire lesson in 10 minutes, right? Like 5 minutes. The only thing that's different here is that I'm going to give you a percentage composition, okay? And I say to you that we have a compound and it is 48.38% carbon. It is 8.12% hydrogen, and it is 43.5% oxygen. And I want you to find the empirical formula. The only thing you have to do differently than you did in the questions you did like last week and over the weekend is assume that you have 100 grams of the compound, because if you have 100 grams of the compound, how many grams of carbon do you have? 48.38. How many grams of hydrogen? 8.12. And how many grams of oxygen? 43.50. So the only thing I need to stress with you is that you must write this assumption down. Or you will lose like a half a mark or something like that. Okay, you don't actually need to show the calculation of how you get the grams of carbon. You can just go directly from the percentage to the mass. Sorry, you had a question. So you subtract this to 100 grams of the compound. Boom, done. So you write down what's in the red box, and from there you have your masses. And then you just do what you did before. We have the mass, we convert to moles, we divide by small, we end up with 1.5, 3, and 1, so we times by 2, and we get C3H6O2. Anything hard today? What was hard today? Oh, you standing and watching? Okay, but other than this, it's all right? You sure you're not playing too many video games? I'm sorry, I'm just bugging you, Aaron. Okay, so, I mean, honestly, how much of this do you need to do in order to have practiced it? Maybe just do like, I don't know, how many examples do we have? Oh, try one of the hard ones. You know what I mean? Like do numbers 4 and 5 or something. Okay. Ooh, number 6 is good. Just do the hard ones, 4, 5, and 6. So 5.7 E, number 4, 5, and 6. That's just to refresh your memory of doing empirical formulas. And then finally, 5.7 D. What do we want to do? How many questions do we have? How about, yeah, odds. Odds? Is good. And then tomorrow we will finish off both the lab and the mole unit. Okay? Because the last thing we have left is combustion analysis. Super fun. Yes. I hide them because otherwise people use them up. They're like, ah!